up, scholars? Today we're going to talk about parallelograms. They are a very, very, very special type of quadrilateral, meaning they have four sides, and the opposite sides are parallel. That's where it gets its name. Let's draw a picture of that. It's got four sides, and the opposite sides are parallel. Now, how do we mark things that are parallel? With these arrows. The arrows mean they are parallel, so those opposite sides are parallel, and these opposite sides are parallel. Cool. So again, a parallelogram is a quadrilateral because it has four sides. Quadrilateral with opposite sides parallel. Cool. So there are four properties of parallelograms that we're going to talk about right now. If a quadrilateral is a parallelogram, I'm going to abbreviate, we can write it all the way out. If a quadrilateral is a parallelogram, then we know four things about it. One, not only are these opposite sides parallel, but they are congruent. So if we have a parallelogram, we know the opposite sides are congruent. Opposite sides are congruent. So that's number one. Number two, if a quadrilateral is a parallelogram, we also know that the opposite angles are congruent. Opposite angles are congruent. That's number two. Number three, if a quadrilateral is a parallelogram, we know the consecutive angles, meaning the angles that are right next to each other, are supplementary, meaning they add to 180. So consecutive angles, actually let's give these some numbers. That could be 60 degrees, and this would be 120 degrees, so when they add up to 180 degrees. Consecutive angles are supplementary. And finally, move my head here, if a quadrilateral is a parallelogram, we know that the diagonals of the parallelogram, which are lines that connect non-adjacent vertices, the diagonals of the parallelogram bisect each other. So this chunk is equal to that chunk, meaning from here to here, is equal to here to there. Okay, and same is true on the other diagonal. From here to that center is congruent to that center to the other side. So the diagonals bisect each other, meaning they split them perfectly in half. All right, so if a quadrilateral is a parallelogram, all four of these things are true. Conversely, if any of these things are true, then you have a parallelogram. So if you see something that has opposite sides that are congruent, you know it's a parallelogram. If you see something that has opposite angles congruent, then it's a parallelogram. If its consecutive angles are supplementary, then it's a parallelogram. If its diagonals bisect each other, then it is a parallelogram. So let's write the converse is also true. If you know any of the four properties are true, then you have a parallelogram. Parallelogram. So if you're trying to show something is a parallelogram, you just have to show one of those four things are true. Or you could show that opposite sides were parallel. That would also show that it was a parallelogram. Cool. You know what time it is. It's example time. Alright, in this example we are given that GKJH is a parallelogram. How do we know from the picture it's a parallelogram? Well, it's got opposite sides that are parallel. That's the very definition of a parallelogram. So we're going to find a couple different segments. How about GK? Segment GK must be congruent to the opposite side HJ, so it's equal to 8. Not bad. How about LH? LH. Well, LH in a parallelogram must be equal to LK, which is 6, because the diagonals bisect each other, so these parts are congruent. And how about K to H? Okay, well if KL is 6 and LH is 6, then 6 plus 6 is 12. Nicely done. Let's do another one. Alright, in this next example we are given that parallelogram ABCD has an angle C that measures 105, and we're supposed to find A and D. We're going to need a picture for this. So let's go ahead and draw a picture. This is too hard without a picture. Crazies. Alright. Doesn't actually matter, but I want C to look like the big one, so I'm going to do A, B, C, D. We know the measure of angle C is 105 degrees. And since it's a parallelogram, the opposite angles are congruent, so that means the measure of angle A is 105 degrees too. And since it's a parallelogram, its consecutive angles, angles that are right next to each other, are supplementary. So we have that 105 plus the measure of angle D equals 180. Subtract 105 on both sides. We'll get the measure of angle D is 75 degrees. Nice. Alright, let's do one more. And our final example here, WXYZ. WXYZ is a parallelogram. So some things should be marked like that these opposite sides are parallel. We're going to find the value of x, like the little x, not the measure of angle x. So we know because it's a parallelogram, these opposite angles are congruent, meaning that 4x minus 9 equals 3x plus 18. 4x minus 9 equals 3x plus 18. We could subtract 3x on both sides. We'll get x minus 9 equals 18 and add 9 on both sides and get x equals 27. Booyah, Grandma. Bunch of geniuses up in here. Alright, scholars, that's it. That is all of the content for quarter 4 e-learning. You made it! Nicely done! I love you so much. I will see you in the real, or come hang out in office hours. That would be wonderful. I would love to see your faces in office hours. Let's do that. Okay. Peace out.